So we talk about design of experiments, and it's a common technique that's used in engineering and science, and now they're applying it to marketing. We want to know what variables are important. We want to know if they interact. And if they interact, then all of a sudden now we have more variables that we have to contend with. An example of variables that interact are like brand and price. And that's that the higher and nicer the brand, the higher the price is going to be. And so because those two are connected, you have to look at how they're going to interact. And so what happens is that you mathematically can calculate out what's significant and what isn't significant. So in terms of setting up a DOE, the first thing is, well, what's your rationale? And so I want to see clothes for tall people. So you pick a response variable, meaning what is it that I'm most interested in? And so sales, my control factors, these are the things that I think drive it. And so it's going to be age, sex, and height. Clothes for tall people, height makes sense. Now I have to pick levels of an experiment, meaning what numbers do I actually want to look at in my sample? Like I can't do everything. So what I do is I pick a couple of levels. Naturally, more levels gives you more accuracy, but then it requires more tests. If I have one variable with 4 levels, one with 2 and one with 3, the way you determine the number of levels is just multiply them all together. And so that means I'd have to do 24 tests. That's a lot of tests. And so in this case, I'm going to pick 2. So for age, I pick the edges of 18 and 50. The thing is, you want to pick levels where you have enough spread, but not so much that they go outside the bounds of what's reasonable. And then I run the experiment. So what I do is I ask people the low value, the low value, the low value, which means if I have a person who's 18, who's female, and who's 60 inches tall, what are the likelihood they're going to buy something? And so based on my surveys, the average comes out to be 30. And then I ask the question, if I give you a product, and I'm forgetting the variables here, and you're 50 years old, you're female, and you're 60 inches tall, what's the likelihood that you're going to buy it? And then they give it a rating of 70. And so I run through all these experiments. And then from that data, from getting this average of sales, what I can do is I can back that out. I plug it into this equation, which is called effects. And that'll tell me which one of these is significant and which one of these is not significant, and whether or not their interactions are significant. Now the way, in terms of significance, you're interested in the absolute value of the number, but the sign actually counts for something. And the reason why is if you think about the sign, if it's positive, it means as I go from low value to high value, it's more greatly valued. If it's negative, it's exactly the opposite. So in this case, if I take age and my slope is negative, then that means it favors younger people. If the slope is positive, it means it favors older people. So the conclusions I can draw from that, and you can just read this, is that sex and height have the largest effect. You can use regression, which is curve fitting, and I have that function on Excel. The thing about data is how can I tell it's significant? I can run t-statistics, and I talked about the significance of the sign. Here's another example. I am not going to explicitly go through it. And the reason why I'm not is, one thing about this class is in my 16-week class, there's a case where you have to look at a DOE and see what it means. The problem in this class is we cover so much stuff and there's only 6 weeks, something had to go. And unfortunately, it was the DOE. Uh, but in this, uh, the paper I give you explicitly goes through it. It's a good idea to read that. I can still quiz you on it. And so the thing is supposing I'm looking at sweaters, what sweaters people like, and so I decide that the big driving factors are going to be color, thickness, and time of year, meaning dark or light, what colors they prefer, do they like thick or thin sweaters, and are they most likely to buy sweaters only at Christmas or any other time of the year? And so I just give it an arbitrary numerical value, in this case 12 and 3. And so these are my experiments. And so I have 2 levels. I have 3 variables, so it's 2 times 2 times 2, or 8 different combinations. And the people I'm going to ask to respond to this are moms and grandmas. And so, again, let's see, what was one? Okay, one is a dark sweater. So if I had a dark sweater that's slim and only at Christmas, I'd ask a mom, okay, well, how would you rate that? How do you think that's the most likely scenario that you're going to purchase sweaters under? And so after getting ratings from moms and grandmas, I plug it into the equation. And so it's the summation of all the high values divided by the number of high values minus the summation of the number of low values divided by the number of low values. And so I could do that and here's the calculation. And I could do it for moms, and I can also do it for grandma too. And so from that, I can figure out what the effects are. And there's actually computer programs that do this for you now. In terms of more analysis, do I have to do all those combinations? No. You could do what's called the half factorial. You could reduce the matrix. There's also something called aliasing, meaning certain tests actually copy themselves. Like at Berman, if you want to figure out how to set up big ones, they actually do it for you. And to do more analysis, you can use ANOVA. And what ANOVA is analysis of variance for those who aren't familiar with it. And that's I have all this variance. Where's it coming from? And what ANOVA does is it separates out, okay, this is where your variance is coming from which variables. When you set this up, you have to randomize your runs. Why? Because you start to build in bias. Don't pick too extreme values, because if it turns out by picking this extreme value it's always 0, then it can skew your results. The thing is, if your data doesn't look precise, rerun it with smaller windows. And how many data points should I get? And you should get at least 10. But the thing is you want to look at what the repeatability is. Ideally, you want 200. That is the statistical threshold. Well, what if I could get 1,000? Why do they pick 200? The reason why they pick 200 is 200 is large enough that you have small enough variances so you can see significance. And the reason why you don't want more than 200, or you don't need more than 200, is what starts to happen is patterns start to duplicate themselves. So you're not getting any new data. All you're doing is getting the original 200 data repeating itself. And that's where that number comes from. So in terms of your survey techniques, these are the questions that you ask about your survey, and you start off with the hypothesis. And your hypothesis is normally, this is why I think people will buy my product. Going back to the Coke, is there a market for a cola drink? The hypothesis is that there's a market for a cola drink in the morning because people need caffeine in the morning in terms of making like a Coke AM. Pre-test your questionnaire to see which is relevant and which is informant. For example, do you like Coke or Pepsi better versus do you prefer cola or coffee? Different kinds of questions. What time do you drink your first soda of the day? And so if you try to go with focus groups, it's because you're trying to find a specific result of how people will react. there might be more than one valid hypothesis for something if there is tests for it. And that's that your a separate hypothesis could be people are drinking 1 a.m. soda beverage because they're tired of coffee and tea because they're too expensive. When you design your questionnaires, make sure that you don't guide the respondent, meaning things like, don't you think, or create emotion that puppies are similar to. Keep it simple. Pace your design, meaning start off with short questions, build up to long questions, and end with short questions, or sporadically put in longer questions. Why? Because if you have long sets of long questions, people's minds start to blur. And the thing you really wanted was straightforward answers and honest answers. Don't ask double-barreled questions like, do you like the price and taste? Stick to one value. How do I measure this? You can make a categorical, which is yes or no or multiple choice. Ordinal is about ranking from worst to best. And a Likert scale, which is the most common, is that give it a rating between 5 and 7 points. Here are the different survey techniques. Again, the first thing to do is it's a good idea to go out and talk to people. Not only that, from your own marketing, you start to build relationships. Here's an example of an actual survey for fast food. And these are the things they're concerned with. How you perceive them, their food quality, how this particular store did, and are you going to come back in the future? And so these are the questions I ask, and it's pretty straightforward. I'll just let you go ahead and read through it. So in terms of survey techniques, these are the different techniques you can use in your sampling, meaning you can go through focus groups, and that's that I'm picking specific experts I want to talk to. Stratified sampling is you divide the population into samples and test each segment. Mall sampling is where you just randomly stop and ask people. Snowball and network sampling is that you ask a core group and then you ask them to tell other people to go fill out your survey. And this is very common in online. Judgment sampling, this is where you do it on the fly. You say, okay, these are the people I want to talk to. These people are just kind of a waste of time. And convenience sampling is whatever's most easiest. And there are pros and cons to each approach. You're looking at it in terms of bias, or you're looking at it in terms of how much noise there is in the data. We talked about the rule of 200. Here are some other ways to test and verify things. Again, is one thing you're concerned about is my data real? Meaning, is it a random occurrence? And so I'm getting truly an honest sampling, or was it systematic? Meaning that it's driven by the way people act. The thing is, if I have a random occurrence and it just happened to coincide with what I wanted to look with, the data doesn't have any value. And so these are the different statistic tests that you use to look at those things. There are a lot of software packages you can use. That's the thing. It's like the old joke. And actually somebody, well, I better not tell this joke because somebody might be rushing to get upset. But the big thing about the world today is you don't need to know this stuff. Why? Because you have computers. A student came up and asked me to do a calculus question, and I told him I haven't done calculus in like 25 years. And so I had to basically take the textbook and quickly refresh myself, and then I could help him. But I don't do that stuff anymore. So that wraps up the first data lecture.